Welcome to the Ash Cloud. I'm Ash Sweeting. Today we are joined by Sarah Place from AgNext at Colorado State University. Her work focuses on sustainable management of livestock systems, including balancing the complex interactions between the economic, social, and environmental impacts of animal agriculture. The complexity of these systems and our human societies means there are no simple solutions.
Where we are today is the result of decades, centuries of choices that people have made. So the thought that, we're going to snap our finger and it's all going to reverse or go to a different state is, I think, sometimes the frustrating part, right? Because it obviously takes a long time to make change sometimes within our systems.
Livestock methane mitigation is an opportunity.
The facts are clear, right? That methane from livestock is one of the sources of methane in the world, right? So we know enteric fermentation is a part of that global methane budget. And I think it's always good to just set the stage of there's no harm in trying to reduce those emissions, right? Particularly if we are holistic about it. And again, we're focusing on those other aspects of sustainability and keeping in our mind at the forefront, livestock is important for livelihoods, livestock is important for human nutrition.
There is much more variation in methane emissions than previously thought.
The data that we've collected thus far, we've had about 900 animal records in the last 12 months, individual animals of methane emissions. We see a wide divergence within populations that are quite similar genetically, right? All the same breed, fed the exact same diet, and we can see variations 30+% between individual animals that have similar performance. So that's a huge variation, right? And so that leads us to our question of, well, who are the rumen bugs, right? Who is there?
The rumen ecosystem is highly complex, and assumptions must be continually reevaluated.
There's a lot of things that affect this complex microbial ecosystem that's inside the rumen that is producing methane emissions, right? And so a lot of our work has been focused on using systems and management systems at a scale. So we have a facility where we can measure up to 300 animals at once on an individual basis. And we can feed them industry relevant diets and actually make sure we're doing a good job of capturing baseline emissions and evaluating a lot of the prediction equations that are out there. And that's really important work because those assumptions about methane based on diet, based on animal type, etc., are the basis of where we get a lot of these estimates from the US EPA or globally, right, from an IPCC perspective of what we assume methane emissions are from livestock. And that's always an important asterisk to this whole discussion is, there's just contention around how many cattle are there actually in the world and, and then how much methane is coming from those cattle.
Methane emissions are heritable.
Past research has shown there is a heritable component of methane, right? So there's something about the host, there's something about the microbiome, and there's something about the interaction that drives these differences in methane emissions we observe.
Current levels of methane monitoring are insufficient.
We need to collect a boatload of phenotypes, right? Thousands and thousands of animals, meaning we have to actually measure methane emissions from thousands of individuals to get a better understanding of those inherent, right, opportunities for genetic selection. And I think that's a big cost, and that investment has not been made in a deliberate fashion and a dedicated fashion.
Solutions must be able to be implemented.
Most cattle in the United States, most cattle around the world, they're grazing. They're out on extensive landscapes. So trying to put a feed additive or something in that management system can be hard. So genetics provides a nice opportunity for permanently reducing and lowering methane emissions without having to have some sort of constant daily cost or management practice that has to be implemented as well.
There is a lot we are yet to know.
And that's part of that complexity when we get back to solutions and people are like, why can't we just fix this issue? And it's like, we're still asking these basic questions, right, of trying to understand the variation that exists within populations, because a 30% difference from animal to animal, I mean, if we have a feed additive that reduces emissions 30%, we'd be pretty happy, right? We're impressed by that magnitude. And I think that's why that's so important to highlight, is that level of magnitude exists just in the population of animals, right? So what is driving it, right? Why is there that big of a variation?
The variation has multiple dimensions.
Within an animal's life, when we measure their emissions multiple times, and particularly knowing this variability that we see, are animals that are low methane emitters on pasture systems or high forage diets still low methane emitters on high concentrate diets? Does that ranking right persist, or is there basically re-ranking as well?
Despite the current focus on methane emissions, there are other vital issues that must not be ignored.
It's an oversimplification, but a lot of our sustainability challenges ultimately come around nutrient concentration, right? Or nutrients being located in the wrong place at the wrong time, and trying to alleviate that, right?
We can learn from nature.
Natural ecosystems clearly do not function without animals, so it kind of makes sense that our agricultural systems need animals as well, right? We need to have those different trophic levels functioning together.
Developing the technical solution is only the beginning.
Coming back to, like, say, greenhouse gas emissions in animal agriculture, right, is how are we going to deliver some of these technical solutions, especially to, say, grazing systems on the enteric methane space, right? We have to think about technically how it happens, but also socially, are we adding labor, right? Are we adding cost in the time of labor, but also, again, time away from family for workers, thinking about the safety of how things are done. All those factors have to be put into it. And I think that's something that we see a lot of times in science is we're good at coming up with, hey, this technical way of doing things is really great, but we don't think about the implementation part of it.
Self-reflection is critical.
Key thing as a scientist is to always recognize there's objective ways to measure progress or change in each one of those areas, but also it's full of value judgments, right? How people put value on each of those things may be different, and that's what can make it challenging. Is oftentimes in the sustainability space, some of the disagreements or arguments are coming from different prioritization of those areas and different views of the problem itself.
Sarah, thank you very much for joining me today.
Absolutely. Happy to join.
Agriculture and the intersection with the environment has been a personal and a professional passion of yours for a long, long time. Could you please tell us why and how and explain that, please?
Yeah. So I'm originally from upstate New York and grew up on a dairy farm. So I feel like my interest in this intersection between agriculture and the environment really came from growing up in a beautiful place and being involved in production agriculture from a young age, right? So kind of knowing and getting exposure to some of those key environmental issues and thinking about water quality and thinking about some of those things up there in upstate New York kind of led me to a path of, even during undergraduate education, going down the route of taking a lot of environmental science classes, trying to learn more, and just being intrigued in that space. And then ended up taking me to UC Davis for a PhD in animal biology and really focused on methane emissions and mitigating those and measuring those from dairy cattle specifically. And there I worked with Dr. Frank Mindlener, and then kind of spent some time in a few different roles since then in academia at Oklahoma State University in a beef system sustainability position, teaching and research there. Spent some time at the National Cattlemen's Beef Association running the Chekhov-funded sustainability research program. Spent some time in for-profit industry at Elanco Animal Health as the chief sustainability officer and really providing more technical expertise, especially to customers, so cattle producers in that space. And then since August of 22, I've come back to academia at Colorado State University, working in the Department of Animal Sciences and with a group called AgNext. So it's kind of a unique initiative at the university that's wholly focused on sustainable animal agriculture and trying to advance the science, but also do a good job of communicating about the science to all the various stakeholders in the space. So my role now is kind of a three-way split from a job perspective. So I do research, I do teaching, and then I also have an outreach component to my job as well.
Okay, and with agricultural sustainability and the three, I guess the pillars are the economic, the social, and the environmental. When we start looking at the mainstream media, frequently much of that, and especially the complexity of that, is often lost. Can you
Mhm.
just run through those three pillars and sort of pull them apart and into the complexity that there is with them?
Yeah. Yeah, and that's part of the challenge with sustainability. We think about those three pillars, the economic, social, and environmental, but then they're also all related and they overlap, which makes it even more complex, to your point. So I think in the environmental, where a lot of the focus is and where a lot of my research focuses, there's several issues, right? Which just kind of again highlights the challenge of balancing all these different concerns. And so one that's forefront in today's world, just because of the reality that we're living in, is climate change, right? So both the effects of agriculture on climate change and greenhouse gas emissions from agriculture and how it potentially changes, carbon cycling, and then also the impacts of climate change on agriculture, which is sometimes not as appreciated, but that's another big part of this conversation and how that could potentially have ripple effects across all those other domains of sustainability. But we can think about obviously water quality, we can think about soil health, we can think about this broader context or issue of so-called ecosystem services or the benefits that we humans get from nature, everything from the aesthetic value of landscapes to right water cycling, water uh, clean the clean water, right, and the filtering of water, all those different functions in ecosystems that ultimately we depend upon for food production, but then also just in general for our environment that we live in as animals, is a part of it as well. So again, that's just the environmental domain, quite a wide array of issues of all different types that fit within it. But then if we think about the social and then the economic, right? Um, economic in today's world, I think with inflation in the US and around the world, that's become more real for a lot of people. Or a wider swath of people. Maybe there's quite a lot of people that said, yeah, this has always been a challenge to make ends meet and to make sure you can afford quality food, right? But that's a big part of it. And of course, everyone in the supply chain, all the way down to the producers, can they have economic viability? What are those barriers or opportunities in that space, right? The economics component of it is rife with trade-offs, right? Really, that's what the study of economics is about, right? Is figuring out how to deal with those trade-offs and how to oftentimes price some of those things into systems. And on the social side, another whole host of issues that we could put into that category, right? Everything from at the end of the day, we're talking about nourishing ourselves and human nutrition and the impacts of food on those outcomes of quality of life for people, right? Making sure we have adequate nutrition, but the whole host of issues that are related to food as well there. And then in animal agriculture, a big part of that social sphere is just the role of the human animal bond and how we treat animals and animal welfare, right? That falls into that domain as well, right? So which in and of itself, animal welfare is a whole nother complex topic, right? And that's just a subset of sustainability, right? So I think um, that's a quick overview of all the host of different issues that could be in that space. And I think a key thing as a scientist is to always recognize there's objective ways to measure progress or change in each one of those areas, but also it's full of value judgments, right? How people um, put value on each of those things may be different, and that's what can make it challenging. Is oftentimes in the sustainability space, some of the disagreements or arguments are coming from different prioritization of those areas and different views of the problem itself, right? We're
No,
talking about
completely.
different things before we even get to solutions, and that can be sometimes part of the challenge as well.
So in my travels, you firstly, I've never actually met a farmer or rancher who has deliberately tried to damage their land.
Right.
They mostly care deeply, deeply for their land. Frequently, it's been in the family for many, many generations, and they'd like it to stay that way. But the economics of having the time, the resources to actually look after the land they want, with the financial pressures they're frequently under, as well as on the social side of things, the communities they come from. And as there's less money in rural communities. People move to the cities, and be that here in the United States, elsewhere in the Western world, or in Africa or Asia or in parts of the developing world, that there's all those that you know that urban migration is a global phenomenon, but then those communities are less vibrant and they're less
Yep.
able to provide the services, and you end up with this spiral. And whilst the
Hmm.
people in the cities are further distant from the food, they just go into the grocery store and look at the price, and they don't actually understand the. And it's not that anyone's wrong and any
Yeah.
finger pointing needs to go on in this. It's just the way our societies have evolved. But
Hmm.
and then that leads to the farmers and ranchers trying to make ends meet, and they possibly take
Hmm.
shortcuts, which can lead to land degradation. You end up with this vicious circle. And on that, we have, I think, be that here in the United States or elsewhere, we've got some pretty good scientists out there in terms of digging into the details, understanding the biology, understanding the ecology. We do, obviously there's a huge amount still to learn, but we've got really smart people who are doing great work in that space. But then when you start looking at how that links back into policy and how that links into financing to actually get the solutions, because if you've just got the science and it's sitting in a beautiful paper on a shelf, there's
Yeah.
no benefit for it. So
Yeah.
in terms of your ideas of how to make that whole ecosystem of science, policy, finance, um, extension or social kind of or communications, what's needed or what can we do better in that space from your perspective?
Yeah. So you've kind of hit the nail on the head of the complexity of it and the fact that, it's where we are today is the result of decades, centuries of choices that people have made. So the thought that, we're going to snap our finger and it's all going to reverse or go to a different state is, I think, sometimes the frustrating part, right? Because it obviously takes a long time to make change sometimes within our systems. Um, yeah, so I think there's a few things there, right? One is just the basics of understanding within each one of these issues how things are connected, right? I think is important. And I think a central challenge in that space to your question about communicating is the pace at which changes are expected, right? And the time that we put into truly deeply understanding each one of these issues, or and not to make that sound like people are not investing the time that they have, right? Because I think building upon the things that you've identified in that social realm, for whether we're talking about producers, primary producers, cattle producers, row crop farmers, whoever it may be, and others, time is such a precious resource, right? And so what we see sometimes is even technical solutions in the sustainability space, right? So maybe somebody comes up with a solution of, hey, if we all did this, we could reduce emissions or make improvements, but they're maybe not thinking through all the social implications of, yes, there's economics and finance and how is somebody going to get paid for this practice, but also, are we thinking about we're going to make somebody's life easier? We're going to improve the workers' quality of life. We're going to get them home to their family faster, right? Sometimes those factors are not thought of either in our technical solutions that we're coming up with. And we can especially think about that coming back to, like, say, greenhouse gas emissions in animal agriculture, right? Is how are we going to deliver some of these technical solutions, especially to, say, grazing systems on the enteric methane space, right? We have to think about technically how it happens, but also socially, are we adding labor, right? Are we adding cost in the time of labor, but also, again, time away from family for workers, thinking about the safety of how things are done. All those factors have to be put into it. And I think that's something that we see a lot of times in science is we're good at coming up with, hey, this technical way of doing things is really great, but we don't think about the implementation part of it. And I mean, oftentimes that can even be present and sometimes in the modeling side of things, try to track and account emissions. There's been so many great models that get produced, but the user interface for them is so cumbersome, or there's so many inputs that are required that they sit on a shelf somewhere, right? So there's many examples of that. But I think what we're trying to do at AgNext is try to think about that in a holistic way and try to engage with folks and have a more iterative process so you can try to anticipate some of these things that we got to come up with technical solutions that can actually be implemented, that can actually be priced into a system properly, right? To make everybody whole. which again, tough order to try to achieve all those things, check all those boxes.
The fact that you're more broadly engaging is wonderful to hear. Do you want to just tell us a bit about the process, how you go about that?
Yeah, yeah. So just to give everybody kind of an overview of AgNext. So AgNext is born out of this idea that we don't have a lot of focus solely on sustainable animal agriculture specifically and the challenges that are present there. And so this was an initiative born out of the university coming from a standpoint of let's pull together resources from the College of Agriculture, the College of Vet Med and Biomedical Sciences, put together this kind of virtual center that lives within the university and just really can focus on this issue in a holistic manner. And not just focus on this issue from a research perspective, but basically give this AgNext, what's become AgNext center, a charge to engage with industry very strongly, right? Industry meaning producers, anybody in that value chain, right? Because right to that question, right, we have to make sure that we're informing folks and hearing from folks on a continuous basis to make sure we're not doing things that are irrelevant, right, from a research perspective. So that's kind of the gist of AgNext. Now there's probably at least 7 or 8 faculty members that are truly hires that are part of this group within animal sciences, within the Department of Agriculture and Resource Economics, and then in the vet school at CSU. And our goal is to keep building towards that, interdisciplinary or transdisciplinary focus where we are engaging with the actual industry on a regular basis. And so those engagements can look like we actually have a formal, industry innovation group where we try to interface with those folks twice a year. And there's representatives of dairy producers, cattle producers, feedlot operators, but also like financial institutions. So we try to hear from all the different perspectives in the room. And that's a big part of that engagement and making sure we're staying up with things. And then honestly, just sometimes one-on-one or sometimes meeting consultations with producers, making sure we're actually engaged, we're a part of the process. That's everything from being involved with, say, organizations like the Global Roundtable or the U.S. Roundtable for Sustainable Beef, to going to Cattlemen's Association meetings, to again, from local to global, a whole array of interactions. So it's time consuming, but I don't know of a better way to try to make sure that you're listening deeply, right, to all those different constituents, hearing what they're saying and responding to that.
It goes back to time and the
Yeah.
value of taking the time to do things and having the time to do things the way that you'd like to do them and you think they should be done.
Yep. Exactly. Exactly.
So the focus of your research has largely been on methane,
Yes.
and it's a contentious issue in many ways because just because there's a lot of people that like to try and blame the livestock industries for the climate challenge. The way I look at it is that there's a solution to reduce methane from animal agriculture. It doesn't mean that that's the cause. It means it's one of the best levers that we have to reduce greenhouse gases globally. So what do you think about that debate, that politicization of that, and what can be done in your mind to address that?
Yeah, it can be a contentious topic. And I think that kind of comes back to, again, the way people are viewing the problem or where they sit. And I think sometimes, folks within, say, like the cattle industries feel like when there's critiques being made, they feel like attacked. And so their response is kind of reflective of that. And at the same time, sometimes folks that maybe are looking at the industry and not aware of it say, well, they're not doing anything right at all in this space, right? So there sometimes can be those like two ships passing in the night of people are just having different conversations or formulating what's happening differently. But I think the facts are clear, right? That methane from livestock is one of the sources of methane in the world, right? So we know enteric fermentation is a part of that global methane budget. And I think it's always good to just set the stage of there's no harm in trying to reduce those emissions, right? Particularly if we are are holistic about it. And again, we're focusing on those other aspects of sustainability and keeping in our mind at the forefront, livestock is important for livelihoods, livestock is important for human nutrition. And I think sometimes where that contention comes in is for a few folks that maybe have that view of, well, the answer is just get rid of livestock, right? And obviously that's usually where all this contention comes from. It's like, rather than working within a system and saying, how can we make it better, there's sometimes that view of, let's push the easy button, not thinking about all the ripple effects that could take place from such a drastic decision. But I think there's a lot of efforts now of being more focused on practical solutions, right? And interest in trying to develop those. And that's, to me, what I think is more exciting, is focusing on that whole holistic range of, okay, how do we roll up our sleeves and get to work and actually try to reduce enteric methane emissions, paying attention to productivity, paying attention to the economic viability of this for producers, the cost of products, all those different issues as well.
So methane is an invisible gas. It's produced by a very complex microbial ecosystem inside an animal that chooses what it eats, that walks around, that grows up in different environments, that's affected by weather, by the quality of the feed it has available. There's a lot of things going on in there. So if you can just tell me about your research, what your priorities there are in this space, where you see the big challenges, where you see the exciting opportunities, and where we see that, we need to understand things better.
Yeah. So we try to bucket the research that we do in this space in kind of 4 different ways. And one is just better understanding baselines, right? So to your point, there's a lot of things that affect this complex microbial ecosystem that's inside the rumen that is producing methane emissions, right? And so a lot of our work has been focused on using systems and management systems at a scale. So we have a facility where we can measure up to 300 animals at once on an individual basis. And we can feed them industry relevant diets and actually make sure we're doing a good job of capturing baseline emissions and evaluating a lot of the prediction equations that are out there. And that's really important work, because those assumptions about methane based on diet, based on animal type, etc., are the basis of where we get a lot of these estimates from the US EPA or globally, right, from an IPCC perspective of what we assume methane emissions are from livestock. And that's always an important asterisk to this whole discussion is, there's just contention around how many cattle are there actually in the world, and, and then how much methane is coming from those cattle, right? So we don't have a really excellent, I would say, equal quality of statistics all over the world. So improving that baseline information is really important. And then building upon that, we can think about it as, yes, enteric methane is produced by methanogens, right? The methane producing archaea within the rumen. And so we want to understand how what we feed animals affects that process of methanogenesis. And so whether that's different dietary types or feed additives, that's a big part of our research as well. So testing those, providing objective information and assessments on different ways to mitigate methane emissions via dietary intervention, basically. And then we're just kind of get started with some collaborations with other colleagues here at CSU to try to better understand those methanogen populations, right? And it's kind of related to the fourth bucket of research. The data that we've collected thus far, we've had about 900 animal records in the last 12 months, individual animals of methane emissions. We see a wide divergence within populations that are quite similar genetically, right? All the same breed, fed the exact same diet, and we can see variations 30+% between individual animals that have similar performance. So that's a huge variation, right? And so that leads us to our question of, well, who are the rumen bugs, right? Who is there? What is happening within the rumen? What are those influences on those different populations? Whether methanogens specifically or more broadly the bigger microbial ecosystem. So that's another area of focus. And then finally for us is interest in genetic selection for methane reduction. And so because been able to collect a lot of methane phenotypes, that's our hope is in the next year or so, we're going to be able to kind of put out some estimates of, based on our data, of the heritability of methane emissions from beef cattle, and then dig into what are some of those drivers there, right? So is it differences in feeding behavior? What is it about the host, the cow, right? The bovine that's driving these inherent differences in methane emissions? Just because past research has shown there is a heritable component of methane, right? So there's something about the host, there's something about the microbiome, and there's something about the interaction that drives these differences in methane emissions we observe. So really sussing that out, especially now that we have the power to collect a lot of methane phenotypes, is super helpful. So that's kind of the area of research that we're digging into, those 4 different buckets. And for the genetics component, I think that part's exciting just because that means we can use genetic selection to reduce methane rather than having to, again, for most cattle in the United States, most cattle around the world, they're grazing, they're out on extensive landscapes. So trying to put a feed additive or something in that management system can be hard. So genetics provides a nice opportunity for permanently reducing and lowering methane emissions without having to have some sort of constant daily cost or management practice that has to be implemented as well.
Last year at a methane summit up in Davis, your work was highlighted where those cattle that came from different locations, I think from memory, it was Fort Collins, it was Wyoming, and it was Nebraska. And the location the animals came from was found to be highly correlated with their emission levels. Have you had a chance to dig into that further to try and understand the causality or what's happening there?
Yeah. Yeah. So that's some pilot data that you would have seen, and we've kind of partially replicated that this past year, and then we're going to more fully replicate it this coming year with a USDA NRCS grant, looking at basically measuring cattle 3 times in their life, right, from 3 different places. So that's of interest for us, is understanding, what are those inherent differences? Are they, again, animal genetics related? And part of it is understanding the differences across management systems, but also within an animal's life when we measure their emissions multiple times, and particularly knowing this variability that we see, are animals that are low methane emitters on pasture systems or high forage diets still low methane emitters on high concentrate diets? Does that ranking persist, or is there basically re-ranking as well? So I think for us, we're just in the throes of really digging into the next round of that research and expanding the number of animals we have in it, and hopefully finding some insights of what can drive those differences, but more importantly, again, can we intervene throughout the life and actually result in a lower footprint across different systems? So that's kind of our goal, is to look at origin by intervention kind of interactions there.
And are you including looking at things like the soil type, or because obviously the animals are interacting with the soil and the soil microbiome, and there's there's layers of complexity in all this.
Yes. This particular study we're not, but I think we have a strong interest as a group of better understanding that, and I think you're hitting on something good of where are these microbes coming from in terms of what is established as differences from animal to animal. So it could be everything from dietary interventions that we have, but I think another key interest for us is just even this process of an animal becoming a ruminant, and how does its microbiome get established, and the potential there for very early life intervention to set an animal up on a different, basically, rumen efficiency path, right? Depending upon the establishment of those rumen microbes. That's an area that honestly is a big, wide open field of. We have lots and lots of questions, and it's definitely job security, because there's many different threads that you can pull on in that entire space.
So it's kind of the nature versus nurture. What is actually hard coded into the DNA, and then what is established as a microbiome because of that environment and whatever the the
Exactly.
vast number of things that impact that environment may be.
Yes. Or is there some sort of life event that kind of shocks the rumen microbiome at some point and then sends it off into a different path, right? So, um, even if an animal, say, gets a respiratory virus and we give it antibiotics, does that have any influence? No idea, right? Any of those, not respiratory virus, respiratory bacteria, right?
Yeah.
That would cause that issue, right? So there's so many unanswered questions that are at that central heart of, yeah, the interaction between the animal and the environment that are wide open. And that's part of that complexity when we get back to solutions and people are like, why can't we just fix this issue? And it's like, we're still asking these basic questions, right? Of trying to understand the variation that exists within populations, because a 30% difference from animal to animal. I mean, if we have a feed additive that reduces emissions 30%, we'd be pretty happy, right? We're impressed by that magnitude. And I think that's why that's so important to highlight, is that level of magnitude exists just in the population of animals, right? So what is driving it, right? Why is there that big of a variation? Um, and thinking about dietary interventions is yet another thing. Are all animals going to respond the exact same way for an intervention? Probably not. What are the inherent differences there? Yeah.
Given the fact that breeding and selective breeding is a tool that livestock producers have been using for centuries and centuries across the entire world. So they're very well versed
Mm-hmm.
and comfortable using. And it's also persistent. You breed an animal with certain traits, and that animal will have those traits for its entire life and then pass them on to their offspring. Um, a lot of people are thinking that this is one of the greatest opportunities to have a lasting and real impact. And given that, what resources, what technology resources, knowledge, people are needed to be put into this space? Because we saw from COVID that when there's a huge global challenge and governments and the private sector and social society throw resources at a problem, they can solve that problem very,
Mm-hmm.
very quickly
Mm-hmm.
when it's a focus.
Mm-hmm.
So, and this, many people would argue, is of equal magnitude. So,
Mm-hmm.
what's needed?
Yeah, on the genetic space particularly, right? I'm not a geneticist, but I would know that phenotype is king. So we need to collect a boatload of phenotypes, right? Thousands and thousands of animals, meaning we have to actually measure methane emissions from thousands of individuals to get a better understanding of those inherent, right, opportunities for genetic selection. And I think that's a big cost, and that investment has not been made in a deliberate fashion and a dedicated fashion in the United States. I think that just this year there was some, funding for enteric methane research, and I think some of the funding has gone to a project that has kind of a genetic component, but not at the scale, to your point, of like, if you're like, I want to be by 2030, I want to have an answer to this, you would have to pour money into that research to collect those methane phenotypes. Um, and a key part of that too is this is some of the work that we're doing that's always maybe less exciting, but we don't have a standardization of how you collect a methane phenotype. And so, like, making sure that differences we observe in data sets are not due to just methodological choices is also very important. So there's a lot of folks that would like to just predict methane off of prediction equations, and based on the incongruence that we see between observations, actual measured methane emissions, and predictions, I would say that's probably not a good choice, right? Because we're going to be missing the inherent variability that's actually out there in the world. And
That's
we're
the
trying to,
opportunity, is understanding that and leveraging that.
yes, you want to actually know the variation, right? And most prediction equations are based off of intake. And so, really, at the end of the day, you're just selecting for intake in some indirect fashion if you use prediction equations. But there's significant variation in methane emissions that's decoupled from intake. And that's what we want to understand, and take the opportunity to exploit, right? Which sounds like a bad word, but really move the needle in terms of, we don't want to have all these animals that basically are over indexed on emitting methane per unit of intake, right? Um, but I think the important thing there is building methane as just one of many production traits, right? Because there's quite strong correlations between methane emissions and body size, methane emissions and growth rate. methane emissions and even feed efficiency in some cases. So you don't want to just select for lower methane and not consider all those other things, because you'll just create smaller, poor growing, less efficient, feed efficient animals, right? If you just select for methane per day, methane emissions per day. Yeah.
So part of that is testing many more animals across their entire
That's the big
lifetime, and
that's the big
then
thing.
having affordable and available equipment that can actually do that.
Yep. Yeah. So the big thing is like, let's agree upon, let's, as the scientific and professional community, create standards of how we're going to measure these emissions, and then go ahead and do it. And that will accelerate us much faster towards this promising area of genetic selection. Yep.
In terms of the standardization of those methodologies, where's that at? Is there anyone who's taking the lead on that, or is that still something that is being nutted out?
Yeah, so we're trying to, in our way, with the systems that we use, which are green feed machines from the company called CLOC. We're trying to create some standardization around that and put out peer-reviewed publications in that space. So we're getting started on that. And the idea is that hopefully, as we amass some more information, we can, go to organizations such as like the Beef Improvement Federation, that has created standard guidelines for how to collect feed intake phenotypes and body weight gain phenotypes, and create similar standards for methane emissions as well. So I think that's ultimately the path. Is we got to do the science, we got to get it out there in the peer-reviewed literature, and then we can, again, as a collective scientific community, with the rigor of looking at evidence critically, come up with some good standards.
As someone who did a lot of work on this for their PhD and has been looking at it quite in depth for quite a while, how hard is it to measure?
It's difficult. Yeah. So yeah, particularly when I was doing my PhD work, that was part of it, was developing a new, what we would call like a head box system to measure methane emissions from individual animals. Um, and so designing that and validating it and getting that up and running was a big part of my work. And I did a similar thing at Oklahoma State University, of creating a head box system. So the challenge with it is, even with those systems, it's quite expensive to design them. It takes a lot of technical expertise to get them up and running and continue to have them to work. And then with headbox systems, put a lot of time and treasure into getting those running. And then for my case, I always had I had two, so that really limits your your experimental designs, right? You're like, yeah, I spent a year of time getting this thing validated, and now I can run an experiment, where I have two treatments, or I have to do really funky, staggering of days and all sorts of stuff if I want to test more. So for example, the technology, the green feed machines have really helped in terms of expanding the capabilities to measure larger groups of animals on an individual animal basis. But I think with methane measurement, it's like anything in science. You have to have tools that are fit for purpose, right? So there's ways to measure methane from groups of animals, etc. All these things that we've been talking about, we have to be able to measure individual animals if we're going to get a good estimate. And the other challenge with measuring methane emissions is, and just speaking from experience of having engagements with different, startup companies and people asking questions, is people say, well, I have a new methane sensor. We can detect methane. That's great, but that doesn't really help, because you need to know not just the concentration coming out of the animal, but you need to have some sort of inference about airflow rate around the animal, right? So emission rates are mass or volume per unit time, right? And so that part of it, of trying to measure a flow rate, trying to get an actual emission rate and inferring that from concentration samples, is sometimes the difficult issue as well. There's folks trying to take different approaches there, but I think it's a ripe area for new investment and ways to more cheaply measure emissions. But it takes a lot of labor currently and a lot of technical expertise to collect methane emissions. There's just no easy way around that right now with livestock.
But as you said before, it's also the hurdle that needs to be surmounted to get to the
Yes.
opportunity. So
Yes. Yes. Yeah. Yep. So there are a lot of folks I think that are thinking about that and thinking about how could they design new technologies, and I think that's great, right? And I hope in the next few years we come up with new methods to measure these important outcomes on animals in a holistic way. And that's one of those things to note as well. It's just emissions, as you had said earlier, they vary by diet, they vary by all these different factors. They also vary within day, especially with animals that are fed in confinement, right? If there's a large jump in methane emissions after a meal. So that adds another layer of complexity of measuring emissions is how many representations of blocks of time do you need? What is adequate there, right? So there's many different questions that come into play.
Thank you. Back to nature and animals. And I was recently reading about the West Coast, United States West Coast forests, the redwood forests and those coniferous forests. And the research is showing that over 70% of the nutrients that have enabled those forests to grow have originally come from the ocean and then been traveled inland through salmon and other animals, and then they're moved and spread across the land by birds, by bears, so that the importance of animals in our landscapes, even our wilderness, I think is greatly underappreciated how vital they are in terms of having a healthy ecosystem. And I think, there's certain correlations between agricultural lands. What are your thoughts on the importance of animals in land, and what could be done there to get the value of animals in the landscape?
Yeah, so that's a whole another area, right? And topic of what we could discuss from a standpoint of the food system and the interactions between basically those different trophic levels, right? Plants, animals, the microbes that are important for both, right? And the transformation and the movement of nutrients. And it's an oversimplification, but a lot of our sustainability challenges ultimately come around nutrient concentration, right? Or nutrients being located in the wrong place at the wrong time and trying to alleviate that, right? Nothing is 100% efficient. Second law of thermodynamics, there is entropy, there will be loss of nutrients in systems, but how do you minimize those losses, or in the case of certain systems, take advantage of those? And I think that's where integrated crop livestock systems kind of highlight the beauty of that, right? So it could be everything from spending time in Oklahoma. I think a great example of a pretty widely used integrated system is cattle grazing winter wheat pastures, right? So we have 1 acre of land that we're using for human food production. That wheat can go be combined and used directly for human food, but we're also grazing it right prior to the grain stage and getting nutrients from those plants that are then transported in cattle right to some other location. And that would be just one of those examples. And also, obviously, thinking about all the byproducts, all the other components of plant agriculture that end up in animals, right? So we're basically extracting further value from those plants that are human inedible or not available to the food system without animals, especially ruminant animals, right? And the largest example we could think of is, of course, all grazing lands with grazing ruminants, right? That's all cellulose, that's all solar energy that's basically completely locked out of the food system without grazing ruminants, right? And the transformations of carbon and the effects on the water cycle and other aspects of that, of having that grazing disturbance in those ecosystems, is really important too. So yeah, I think it's always a intuitive point that sometimes can be overlooked of, natural ecosystems clearly do not function without animals. So it kind of makes sense that our agricultural systems need animals as well, right? We need to have those different trophic levels functioning together. And it's just more of a function of when, where, how, right? Should those things be happening? And then as soon as we say should, then we get back to all the social issues and the policy choices and everything else, right, in that space. So yeah, that's that complexity of it. But I think sometimes just simplifying it down, as you had pointed out, right, if we just think about the evolutionary history of life, like everything started in the ocean and then it moved to land, and a lot of that movement was happening because of mobile organisms, animals, right, moving it.
Yeah, it goes back to, I guess, some of the traditional agricultural practices, especially in the more arid areas of the Middle East and Africa, where
Yeah.
you'd have farming in the oases, and then the goats and sheep would graze, and they'd bring the nutrients back to the
Yes.
oases, and what they
Yes.
call wadi agriculture. And it was all the animals were actually what scavenged the desert for all the nutrients and enabled you to grow crops, whatever they happen to be in those areas.
Mm-hmm. Mm-hmm. Exactly. Yep. And that is the beauty of animal agriculture, right? Is it is mobile, but we have, in response to trying to feed more people more efficiently, of course we've immobilized some of those systems and concentrated them as well, which has created opportunities for much more production, but creates challenges from a standpoint of nutrient management, right? And potential for too much nitrogen, too much phosphorus being in certain areas as well. So it's always trade-offs in this whole discussion of um, it's hard to check all the boxes simultaneously.
Wonderful. Before we go, is there anything that we haven't discussed that you'd like to add?
Yeah, I think we've covered a lot of the ground from a standpoint of the climate impacts and stuff of cattle and that enteric piece of it. But I think just coming back to this discussion we just had, I think that's that holistic view of basically methane is just a byproduct of this process that we're just talking about of degrading inedible plant materials, right, in a pretty quite honestly a pretty efficient way in the rumen. And I think that's one of those things that sometimes gets missed is that's that's back to why we don't want to push that easy button of just let's get rid of livestock, because these animals, especially ruminant livestock, are adding a lot to the food system as well. So whether it's those integrated crop livestock systems or taking advantage of all the grazing lands that we have available and thinking about those grassland ecosystems, I think that's a part of that balance that needs to be elevated more as we want to mitigate methane emissions, but we also need ruminants, in my opinion, in our food system to make it as sustainable as possible. There's a key role they fill there.
Sarah, thank you very, very much for joining me today.
Absolutely. Thanks for having me. Appreciate it.
You've been listening to The Ash Cloud with me, Ash Sweeting, in conversation with Sarah Place, recorded in California in February 2024.